Hello and welcome to my channel. My name is Andreas Vanax, and today we're going to discuss how the Romans enumerated sets. A set is a series of numbers. It could be years, it could be days, it could be things. And we also talk about leap day error. And in general, this is a clash of cultures. You have the Romans saying something repeats every so many days is called this, and the Greeks and Egyptians saying no, it's called this other way, and you end up with a confusion. And it's like a comedy of errors that led to the error in which the leap day was implemented initially in the Julian calendar. Now, in the prior episode, we're talking about the chronograph of 354 AD. It's available at this link. If we go there, we have the Philokian calendar. This is the calendar for actually 355 AD, the next year. And they numbered the days. And they numbered the days of the week. Initially, the Romans had an 8-day week. And over time, by the time 350 years after the birth of Christ, the influence of Christianity and Jewish culture was to the point where they started using also the 7-day week. Eventually, the 8-day week completely died out, and only the 7-day week remained. This column right here, and the Romans didn't have any numbers. They didn't have a zero, and they didn't have numbers, believe it or not. They had letters. So A would be 1, 2, 3, 4, 5, 6, 7, and then it repeats again, 1, 2, 3, 4, 5, 6, 7. So the first column corresponds to the Christian or Jewish week of 7 days. And the second column corresponds to 1, 2, 3, 4, 5, 6, 7, 8. And then it repeats again. It corresponds to the 8-day week of the Romans. And the Romans had their market day, or when they set up the shopping stalls and markets on H, which was the 8th day. But when we go find out what was that week called, we find that it was called the Nundinae. If we go to the Wikipedia article on this, the Nundinae were the market days of the ancient Roman, forming a weekend, and the Nundinal cycle was an 8-day week. From letters that went from A to H. And you can see them in the old calendars here, the frescoes of the remain of the Roman calendars. But the interesting thing is the Nundinae mean 9th day. Why would that 8-day week be called referring to the 9th day? That's a complete mystery, and that's the key. That's the clue that solves the Roman census, believe it or not. And it's also the reason why they messed up so badly when they're trying to implement the leap day years. So I'll talk in a second. So there was a Roman author who wrote a book for his patron. He was a Roman consul on his birthday. So he talks about the natal day, in general, how to calculate time, how the Romans calculate time. It's written 230 AD, so it's pretty much in there, not that far from the time period we were discussing, which is the birth of Christ. And like I explained, you can find this book in Google Books. You can download it, and I have it here. And he's variously translated. It was written in Latin, and he's variously translated the natal day, which is a direct translation, the dia natale, or sometimes people call it the birthday book, because it was a book written for his patron's birthday. And appended to that is another book we're not going to talk about. 238. You can read this book. It's very short. It's packed with information. Most of this is just. This is the introduction. Okay, here we go. And it's only a few pages, like 14, 10, 15 pages, something like that. So it's a good thing if you read it in full. But I pulled out some quotes in here. And here he explains how the Romans counted sets. He says that something out of a revolution of 2 years was called a trietary, a cycle of 3 years. Because it repeated on the third year. So you have the first year, the second year, the third year was when the cycle repeated itself. So you had the first year and the second year. So they called it a cycle of 3 years, or the 3-year cycle. He also says, this is a direct quote, and established tetrateries, a cycle of 4 years, which returning every 5th year was called pentateries. So a cycle of 4 years was called pentatary, and penta means 5. So to the Romans, a 5-year cycle corresponded to 4 years. A 3-year cycle corresponded to 2 years, because in their mind, it repeated on the 5th year. And then he says the pentatary, and the 5-year cycles, which are actually 4 years, was doubled, and then it was called the octataries, a cycle of 8 years, which really they called eunetetaries, a cycle of 9 years, because this year returned the 9th year. So the nondinae, which was the name of the week, repeated on the 9th day. So it was also a euneatary, which means 9. And it was an 8-year cycle. So you have this clash. I mean, you have to be very careful to understand a Roman talking to a Greek. No, the problem is the Romans didn't have numbers. They didn't have numbers. They had letters. They didn't have number 0. They didn't have any scientists. Most of the scientists were actually in Greeks and Egyptians, and they lived in Alexandria in Egypt. In fact, the famous book, the Almagest by Ptolemy, was written in Alexandria in Egypt. And with it, you could calculate eclipses, do all sorts of mathematical stuff. It was all done by Egyptian Greeks. If they were to talk to the Romans, they'll be in trouble because they didn't talk the same language. I'm talking about mathematical language. For us, 8-year cycle is something that repeats, and that has 8 years and repeats every 8 years. They called it a 9-year cycle because on the 9th year, the cycle repeated itself. It's bizarre, and that confusion remains till today. Our best scholars and our university professors and our historians are all confused. They have no clue. All they have to read is Censorinus. Censorinus is actually the only book that survived from the Roman times that talks about periods of time. So it's not like they missed the book. That's the only book. And if they read the book, then they lack reading comprehension. I mean, this is just mind-boggling. I mean, they need to get on the ball and correct their mistakes. I'm talking about our current university professors. They don't know what they're doing. Um, in any event, for the Romans, the 4-year Olympic Games were called the Pentateuch, the 5-year games. Caesarino says this is why, in the return of every 5th year, the games are celebrated in Elis in honor of Jupiter Olympius at Rome, in honor of Jupiter Capitolinus. So the Olympic Games were celebrated in Greece, in Elis, in the city of Elis, and they were at the same time, on the same dates, were held in Rome, and they were called the 5th-year games or 5-year games. He says that further down, the most commonly adopted by the Greeks is the Pentateuch, or revolution of 4 years. 5-year games, which is a revolution of 4-year games, which they call the Olympiads. So there you go. And this is important when we read Josephus, where the Caesar's 5-year games is mistranslated as being occurring every 5 years. They're actually every 4 years, and they were the Judean equivalent to the Olympic Games. Now we come to the censuses. For the Romans, a 4-year census was called a Pentateuch, which consisted, and they call it a 5-year lustrum, even though it was 4 years. So Censorinus tells us, the great year, thus form of 4 years, was more convenient. And this fraction enabled a full day to be added every 4th year. Blah, blah, blah. This is why, on the return of every 5th year, the games are celebrated in Elis in honor of Jupiter. So he's talking about the Olympic Games. And then he says, the great year of the Romans is the same thing as the interval of time in which they are called the lustrum. So first he talks about the great year. The great year is the same as the Olympic Games, and the great year consists of 4 years. Let's highlight that. And then the great year of the Romans is the same thing as the interval of time which we are called the lustrum. The lustrum is a period in which the censuses were held. Dates back to Servius Tullius, who ordered that in every 5th year, we should solemnly proceed, after having made the census of the citizens, to a closure of the lustrum. People read this, lacking reading comprehension, and they think, oh, if you close the lustrum every 5th year, after making the census, then the census has lasted 5 years. No. The census has lasted 4 years. As I show here, you have the census and lustrum. The lustrum is a period of time in which the census was held. So you have the 1st year, the 2nd year, the 3rd year, the 4th year. Then you close the lustrum on the 5th year, which is the same as the 1st year of the next lustrum. Then you have the 2nd year, the 3rd year, and the 4th year. And that is the key to solving the mystery and the misconception and misunderstanding of when the Roman censuses were held. So next we'll talk about the debacle. I mean, the complete disaster is so embarrassing for the leap day error. Let's talk now about the leap day error at the beginning of the Julian calendar. And this will bring home and make it a point as to the clash of cultures between how you enumerate sets, numerical sets, between the Romans and the Greeks. Censorinus tells us that the Julian calendar was implemented in Julius Caesar's 4th consulship, which we have dated astronomically to have been on January 1st of minus 43, that means 44 BC. He tells us in his book, and to take account for the quarter of the day, which seems to complete the solar year, Caesar ordered that after each revolution of 4 years, there should be added after Terminalia. Terminalia was the 23rd of February. Instead of the ancient month, an intercalary day, which is now called the leap year. from this year ordered by Caesar. All those that passed down to our time are called Julian, so it's called the Julian calendar, and they commenced on his fourth consulate. Now, in addition to Censorinus, there was another Roman author called Macrobius. You can see him here. And he writes around 430, about 200 years later. And he's just talking about the festivity of Saturnalia. But he mentions something very important. He mentions how the calendar was implemented. You can find the book here, and if you pull up that book, let's see. Yeah, there it is. You see, for example, the book has pages, numbered pages, but at the same time, the PDF version has a different number. So I always say page 97 or 104 in the PDF version. You can download that book and read what he says. One of the quotes, he says, "He ordained that the priest in charge of months and days should insert one day every fourth year in that month." And in that part of it, in which of old an intercalary month used to be inserted, that is to say, immediately before the last 5 days of February, this intercalary day he ordered to be called Bisextus, as doubling the 6th day before the calends of March. Now, we're used to having our leap day on the 29th day of February. So February has 28 days, and then every 4 years we have one that's 29. But that's only very recent. It's only like 500 or 600 years. For the first like 1500 years, the leap day used to be on the 24th of February. And then they didn't want to change the numbers, so the leap day was a second 24th. They had 2 days. So the February 23rd was called the Terminalia. And then the 24th was the Bisextus. And that's because it's 6 days before the calends of March. March is 31st, 31 days. February had 28 days. So the 1st of March would be 1, and you back off 6 days, and you end up with the, let me see, is that correct? Let us check. Insert table. So here's the 1st of March, 28, 7, and this is the terminal, 23rd. So you count 1, 2, 6. Yeah. So the 6th day before the calendar of March would be the 24th. He explains the error, in which they proceeded to insert an intercalary day, which represents the 4 quarter days, at the beginning of each 4th day instead of at its end, although the intercalation was made at the end of each 4th year and before the beginning of the 5th. This is kind of difficult to understand because he's speaking Roman. But basically, what happens is they intercalated on every 3rd year instead of every 4th year. So, if we go to our list that has been fixed by astronomical means, we know that the Julian calendar was implemented on the his 4th consulate, on minus 43 BC, which is minus 43 astronomical year, which is 44 BC, on January 1st. So that's the 1st year. So we can insert a column here. and say that's Roman Julian calendar. And year one is this one. Simple. Now, we realize that is not what happened. You would expect that, the astronomers from Greece and Egypt tell the Romans, hey, you need to put a leap day every 4 years. And the way the Romans counted, that meant every 3 years, not every 4 years. A cycle that repeats every 4 years is actually 3 years. So this is the actual Julian calendar. And this is what ought to have happened. 1, 2, 3, 4. And that ought to have been the leap year. But no. What happened was the Romans started 2, 3 doing their intercalation on the 3rd year. Isn't that mind-blowing? That is mind-blowing. Because of the clash of cultures. A year that repeats on the 4th year, or a 4-year cycle, is a year that has 3 years for the Romans. So you end up with a situation where they started intercalating a day every 3 years. Instead of what should happen, which is every 4 years. Now, what was the effect of that? This is ridiculous. The effect of that was the Roman calendar started getting ahead. So here, you start the calendar, and the Julian calendar is on the 1st year, and there's zero difference. But then the Roman Julian calendar, the incorrectly implemented Roman calendar, decided to do a leap year too soon. So you were 1 day ahead on this year. And here is where you catch up and you go back to 0. So now you're okay. But here you go ahead 1 day ahead again. You're 1 day ahead until you catch up. And here you're 1 day ahead, 1 day ahead, 1 day ahead. And here they cancel each other, so you're still 1 day ahead. 1 day ahead, 1 day ahead, and then you're 2 days ahead. And then you catch up. So the error keeps accumulating. You're in the wrong day. It says that this continued for let's see what Macrobius says. They proceeded at the beginning instead of the end, at the end of 4th year, at the beginning of the 5th. So the way the Romans interpreted it was that you should have a leap year on the 5th year, which is the 1st year of the 4 years. So every 4 years you get 1 because you're doing it on the 5th year. That's what Macrobius is saying here. Error continued for 36 years, by which time 12 intercalary days had been inserted instead of the number actually due, namely 9. So from 9 to 12, you're 3 days over. But when this error was at length recognized, it too was corrected by an order of Augustus that 12 years should be allowed to pass without an intercalary day. So then you have 12 years without a leap year to balance everything out. Since a sequence of 12 years would account for those 3 days too many. In the course of 36 years have been introduced by the premature action of the priests. And after that, as ordered by Caesar, the intercalary date was to be inserted at the beginning of each 5th year. So even in 430, the Romans were still counting sets like this, where your leap day is on the 5th year, not the 4th year, because the 5th year is the 1st year. Well, a mess. Now, we can go ahead and figure out exactly when everything happened. Because Macronius says this happened for 36 years. So, So we're going to track it for 36 years. There. So we're going to repeat this comedy of errors. So let's see. For 36 years, you're back to 1. You're 1 day off, 2 days off, 2 days off, 1 day off, 2 days 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 off, 3 days off, 2 days off, 2 days off, 3 days off, 2 days off. No, three, sorry. 3 days off, 2 days off, 3 days off, 3 days off, 3 days off, and 3 days off. So after 36 years, you're 3 days off in your calendar. And then Augustus ordered that for the next 12 years, so let's put it here, 1, 2, there shouldn't be any intercalation. So they start counting we don't need to do that anymore. So it's 3 years off, 3 years off, 3 years off, and because there was no intercalation on that year, in fact, let's make it yellow. So in this year, there's no intercalation, so the error removes by 1. 2, 2, 2. It removes by 1. So now it's 1, 1, 1, 0. So it finally went back to the current. So we did that for 12 years. And then the next leap year, you go back to doing intercalations every time. There you go. 0, 0, 0, 0. Isn't that amazing? That the whole error was caused because of the clash of cultures. The Romans thought they were talking about a 4-year cycle, which means it repeats on the 4th year, which means it's every 3 years. And the Greeks were saying, no, it's every 4 years means every 4 years. My God! And that's the great debacle of the Julian calendar. Now, how does that affect Christianity? Well, first of all, it affects the census, explains the census. But then, notice this. This is really interesting. On Jesus Christ's birthday, which happened on, as we'll see, happened in year 1 AD, which the historians are completely off. They're just spewing, but there's baseless speculation, spewing garbage. We see that we're 1 day off from the calendar. So the Romans thought, for example, that it was December 25th, but they were 1 day off. It's actually because they were ahead 1 day. It's actually December 26th. Let's leave it at that. The way the Romans counted sets is different than what is currently understood. And Censorinus tells us directly, in no uncertain terms. I mean, you have to have reading comprehension to mistake it. That the great year formed of 4 years, is the same thing as the interval of time which they have called the lustrum. And they did the census of the citizens and then the closure of the lustrum. So the census was every 4 years, not every 5 years. And we'll discuss that in our next episode, next video. Once again, thanks for watching. The best thing you can do for me is subscribe and watch my videos. I think of this as a class, teaching you how to calculate the dates yourself. I mean, I show you how to find the documents, I show you how to do the searches, I show you how to use the programs. And the way I think of it is as a class. And you're learning what historians are not teaching you because they're all clueless. And it makes me angry. So I'll see you in our next class.